Topic number 18 is reduction formula. Here we are going to learn the reduction formula for sine per nx dx and cos per nx dx, and also we are going to derive the expression formula for integral over the limit 0 to pi by 2. Okay, we are going to fix the limit as 0 to pi by 2 and we are going to find the formulas for those things also. Right? So now let us start with integral sine power nx dx. In a similar manner you can proceed for cos per nx dx by your own. Okay, so let us start with this integral sine power nx dx. So this n I can write it as n minus 1 plus 1. So this is equivalent to integral sine power n minus 1x into sin x dx. Okay, so this is nothing but u and this is nothing but dv. So I am going to use integration by parts. By integration by parts, we have integral u dv is equal to uv minus integral v du. Okay, so u is nothing but sine to the power n minus 1x and dv is nothing but sin x dx. So from dv, if we want v, we are supposed to integrate this term. So v will be equivalent to integral sin x is minus cos x, and same way when you come to this part, differentiation of u is du, which is equivalent to n minus 1 sine to the power n minus 1 will give you n minus 2. So this is sine power n minus 2x and differentiation of sine is cos x dx. So by integration by parts, it is integral u dv will be equivalent to uv. So already we have a negative sign with the v, therefore it is minus sine n minus 1x into cos x minus integral v du. V is nothing but minus cos, so minus into minus will become plus cos x into du, that is n minus 1 sine to the power n minus 2x cos x dx. So cos x and cos x will give you cos square x. So this is equivalent to minus sine to the power n minus 1x cos x plus n minus 1, I am taking it outside as a constant. So the remaining will be integral cos x into cos x will give you cos square x into sine power n minus 2x dx. Okay, cos square x can be written as 1 minus sine square x. So I am going to use the identity cos square x is equal to 1 minus sine square x. So this will be equivalent to, let us take the previous expression, that is minus sine power n minus 1x into cos x plus n minus 1 integral, instead of cos square x, it is 1 minus sine square x sine power n minus 2x dx. Okay, we are just going to multiply with these two terms and write it as two different expressions. So this is equivalent to minus sine power n minus 1x cos x plus n minus 1 times integral sine to the power n minus 2x dx, then minus of n minus 1 integral. So what will happen to these two combinations? 2 will get cancelled and it is simply sine power nx dx. Okay, and in your left hand side you have integral sine power nx dx. I am just going to take this term to this side. So this will become plus n minus 1 integral sine power nx dx. This is equivalent to minus sine n minus 1x cos x plus n minus 1 integral sine to the power n minus 2x dx. So now if you take integral sine power nx common, what will happen? This will be 1 plus n minus 1 times of integral sine power nx dx. 1 will get cancelled and remaining will be n into integral sine power nx dx. Same way on the right hand side you have the same expression as it is. So therefore the integral sine power nx dx will be equivalent to minus sine n minus 1x cos x divided by n plus n minus 1 divided by n integral sine power n minus 2x dx. So this is the reduction formula for integral sine power nx dx. In a similar way you can try it for cos power nx dx. Okay, so if you do it for cos power nx dx, you will be getting it as integral cos power nx dx will be equivalent to sin x cos power n minus 1 by n plus n minus 1 by n integral cos n minus 2x dx. So this is the reduction formula for cos. Now we are going to evaluate the same reduction formula over the limit 0 to pi by 2. So let us find the value of integral 0 to pi by 2 sin power nx dx. So we already know the value of this expression without the limit. So let us call this as I suffix n. Let I suffix n be equivalent to integral 0 to pi by 2 sin power nx dx. So this is equivalent to, we already derived the expression as minus sin power n minus 1x cos x divided by n. So over the limit 0 to pi by 2 we are going to find plus n minus 1 by n integral 0 to pi by 2 sin to the power n minus 2x dx. So what will happen when you apply the limit as pi by 2, cos term will become 0. When you apply the lower limit as 0, sin 0 will become 0. So obviously for both the limit this is going to become 0. So the remaining is n minus 1 by n integral 0 to pi by 2 sin power n minus 2x dx. So you are just going to denote this by I n minus 2. Therefore I n is equivalent to n minus 1 divided by n I n minus 2. Okay. So this is the expression. Based on this expression we are going to deduce the cases. So let us consider the first case. So we have derived the reduction formula and we have arrived at I n is equal to n minus 1 by n I n minus 2. Now we are going to discuss two different cases when n is odd and when n is even. So first let us discuss the case 1 when n is odd. When n is odd. So let us fix n is equal to n minus 2. So this will be equivalent to n minus 3 by n minus 2 I n minus 4. I n minus 4 will be equivalent to n minus 5 by n minus 4 I n minus 6. So if we go on like this, we can find the value of I5 as 4 by 5 I3 and I3 will be equivalent to 2 by 3 I1. We can easily evaluate the value of I1 using the integral In. Okay. So I1 will be equivalent to integral 0 to pi by 2 sin power 1x dx. So integral sin x is minus cos x over the limit 0 to pi by 2. When you apply the limit, this is minus of cos pi by 2 minus cos 0. Cos 90 is 0 and cos 0 is 1. So minus of 0 minus 1 will give you the value as plus 1. Okay. Therefore I1 is nothing but 1. Therefore I3 is equivalent to 2 by 3 into 1, which is 2 by 3. So we can write the value of In as n minus 1 into n minus 3 into n minus 5, so on till 2 divided by n into n minus 2 into n minus 4, so on till 3. Okay. This is the formula for n is odd. Now we are going to discuss the case 2. So in case 2, we are going to take n as even. When you fix n as even, let us write what is I n minus 2. I n minus 2 is nothing but n minus 3 by n minus 2 into I n minus 4 and I n minus 4 is equal to n minus 5 by n minus 4 into I n minus 6 and so on. Now let us try for I4. What will be the value of I4? I4 will be n minus 1, that is 4 minus 1 will be 3 by 4 I2 and I2 will be equivalent to 1 by 2 into I0. So now let us find the value of I0 using the integral 0 to pi by 2 sin to the power 0x dx. Anything for 0 is 1. So this is simply 0 to pi by 2 into dx. When you integrate dx, this is going to give you the value as x over the limit 0 to pi by 2. So the answer is pi by 2. Therefore the expression for In for n is even is given by n minus 1 into n minus 3 into n minus 5, so on till 3 into 1 divided by n into n minus 2, n minus 4, so on till 4 into 2 into finally everything will be multiplied by pi by 2 since this is for even. Okay, so these two are the formula for n is equal to odd and n is equal to even for integral 0 to pi by 2 sine power nx dx. The same way you can derive for cos power nx dx over the limit 0 to pi by 2. Okay, so I will stop with this. Thank you.